Docker fundamentals. What is Docker? So Docker is a container technology, and what it allows you to have a isolated environment, specifically when you're trying to build a application and deploy. And why it is so important. The key reason for Docker to be so successful and valuable to developers is that if you're writing an application, developing something, and during the course of development you add a lot of packages, libraries, dependencies. And what happens is that in earlier days, when you write an application and when you develop it, you give the package to the production team and they deploy it. Oftentimes some of the packages will be missing, and which has led to numerous issues where developer says, hey, it works on my laptop but doesn't work on production. So to resolve that problem, to have a consistent environment, Docker allows it to have it, so that you can actually not only application but also the environment of the application you can package into a single container image, and that container image could be shared across the team or across the globe. Second, isolation. It allows you to have a decent isolation and security even though you are running on the same operating system or the host OS. Example, if you are running two processes, both processes could be running on the same Linux, but there is a opportunity that they can interfere with each other, maybe in a some kind of, because they will be running on the same root file system. Even though Docker runs on the same guest OS, it gives a lightweight virtual environment for each and every application, which allows it not to interfere with each other. And that has been a very good way of deploying application and while keeping the host operating system secure. For example, if you're playing with a new library on your application, and if you don't want to mess up the library of the host operating system, it's a very easy way to test it out. Because remember, if you mess up any libraries on the host operating system, it will impact all other applications running on the system, and which is not often desired case. Number three, container based development ensures a consistent behavior, as already mentioned. And now you can actually replicate the behavior, dev, test, prod, by standardizing the application and packages. And in later on, we'll talk about how a Docker file could be a building block for your any infrastructure as code delivery. Take this example. In this example, I'm deploying an application which has static web page, database, web front end, message queues, and analytics DB. And I need to deploy it on a multiple environment throughout the life cycle of the application. If I didn't have a unified way of packaging and delivering, probably I will be having multiple packages. Example, the application might be running on a Java and message queue is a completely different software, and I'm deploying a two different database, all with a different platforms. So now it creates a lot of complexity in how I will manage version control and automate it, and at the same time making sure it is deployed consistently across the environment to avoid any environment issues. Remember, environment issues is the single most cause of problems in deploying complex application. However, if I have the some kind of container technology or some way of packaging all the application into a single unified way and put in some kind of image that can be shared across all the environment and deployed consistently, that is where the Docker or any kind of container technology chimes in. Because in a legacy environment, if you have to deploy say Java application, .NET application, database, you will be dealing with a lot of environment issues on the production side itself when you are actually deploying. Because remember, if you have a VM, the package could be different, or particular Java version could be different on QA than a prod, and it can cause a lot of problem. But if you package that into a container, then what you do is, in a container, you always package the application and the package and the platform all together. So even though developer and QA instance, the Java version, underlying Java version on the operating system might be different, but you can make sure inside the container, whatever the version of Java I'm using, it is exactly what my application need. So It is completely independent of what is running on the operating system, and you can be sure if your application runs on dev instance, it will work on QA. However, of course, provided other things remain same, meaning your application will not fail due to environment issue. It can fail for some other reason, maybe networking or other configuration, but at least one less variable to worry about. Whenever we talk about containers, conversation always start in a context of virtual machine versus container. Even though these technologies are not same, but they are similar, because most people are familiar with VM and now they want to embark into container journey. For that purpose, this is a very good illustration. Example: here I have a VM and a container, and the key difference between VM and a container is the host operating system. In case of container, you are sharing the same host operating system across all the containers. On the case of VM, you are actually installing a brand new VM for each and every application. This could be very depending on your application requirement, but it could actually dramatically increase the overall footprint needed to run an application. Assume for some reason your application ABC needs to run on a separate VM. Then you're talking about considerable amount of RAM allocation and a root disk allocation. Despite having a QCOW based image, you can still end up having a lot of space wasted. On the other hand, if you have a container based solution, you can actually run on the same operating system with minimal resources. And because containers are essentially behave as an application or a process in the operating system, you will be able to manage them effectively from the operating system itself and even kill the application. In case of hypervisor, you will need a hypervisor software. Most dominant, like um, enterprise software, they could cost considerable in licensing fee as well. So having some running in a Docker or a container based solution could actually save you a lot of licensing cost as well. This is the table explaining difference between the container and the virtual machine. Number one, the architecture. In container, they share the kernel. What does it mean by that? It means all these containers are running on the same operating system. They will be visible. If you do PS or you do a task manager, you will see they are running. On the other hand, in case of virtual machine, they are running on top of hypervisor, and hypervisor will not be able to see individual process running inside the VM. It can only see the VM. So assume if you want to kill an application inside a VM, you have to either log into the VM or you can kill the VM altogether. There is no way you can selectively kill an application from the hypervisor. Isolation, as I mentioned, it is a process level isolation, and VM it gives you full isolation. Performance is something you have to be careful in that. We cannot see container are like better or virtual machine are bad. Nothing like that. Nothing is better or worse. It's just depending upon your requirement. Container are definitely are very lightweight, fast to start, and takes low resource overhead. Mean they don't require a dedicated root file system. Container images are very small, could be 10 MB or something like that. On the other hand, for virtual machine, you need to have a dedicated RAM, you need a root file system, and that adds up once you scale the application. Use case, even though container started as a more of a microservice based architecture, but now container are used everywhere. VMs have been there for a long time and they will be there, and they have their own benefit, and they're very good for running monolithic application. Management: to manage containers, you need to have some container orchestration tool like Docker Swarm, Kubernetes, Slurm. And for virtual machine, you will use standard packages like VMware, Hyper-V, VirtualBox, Linux KVM.